let x represent the number of policies. The MGF of x is given below. Calculate the standard deviation of x. So now we know that the expected value of x power n is the nth derivative of the MGF at 0. And for the standard deviation, we would need the e of x and the e of x square. And therefore, we need two derivatives of the MGF. So let's take the first derivative. The first derivative would just be 0.45 e to the t. And here you'll pick up a 2 after you take the derivative of e to the 2t. So 2 times 0.35 is 0.7. So plus 0.7 e to the 2t, 0.45 e to the t plus 0.7 e to the 2t. And here you'll pick up a 3. So 3 times 0.15 is 0.45. So 0.45 e to the 3t. And then you'll pick up a 4 here. So 4 times 0.05 is 0.2. And then to get the e of x, you evaluate this derivative at time 0. So e to the 0 is 1. So you just add these coefficients and you get 1.8 for e of x. And now we need the second derivative. So take the derivative of the first derivative. So 0.45 e to the t plus 0.7. And here you'll pick up a 2. So 1.4 e to the 2t. And here you'll pick up times 3. So 3 times 0.45 is 1.35 e to the 3t. And then 4 times 0.2 is 0.8 and e to the 4t. And e of x squared is n double prime at 0. So you add the coefficients and you get 4. So the standard deviation is the square root of e of x squared minus ex whole square. And we get 4 minus 1.8 whole square root, and it's 0.87. That's choice B.